Hey you guys, this is Mr. Millings, and in this video we are going to learn how to use the density formula to calculate the volume of a regular shaped object, and then in this particular example we're going to use the volume of a sphere formula to figure out the radius. And so if we take a look at this problem here, it says to determine the radius of a 0.543 kilogram nickel sphere, we want to round the answer to 3 significant figures. So in this problem here we have a sphere, and we know that the sphere is made out of nickel, so this is a nickel sphere, and we also know that the mass of this sphere is 0.543 kilograms. What we want to do is we want to determine, based on the given information that the mass is this and the substance is nickel, we want to figure out what the radius of this sphere is going to be. And so if you take a look at this problem and you think about it, what we're going to have to do here is we're going to have to use the density formula, right? D equals m over v, or density equals mass over volume. And what we're going to have to do here is use this table of densities and find nickel in here, and that's going to tell us D. We also know the mass. The mass is 0.543 kilograms. So what we're going to have to do is we're going to have to use these two values to find the volume of this sphere. And once we're done finding the volume of the sphere, we will then have to plug that value into the volume of a sphere formula, right? We'll plug this value here into here, and then we will end up solving for r. The volume of a sphere is equal to 4/3 pi r cubed, so we'll find the volume of the sphere using the density formula. We'll plug it into the volume of a sphere formula, and then we'll solve for r. But the very first thing that we have to do before we can do any of this math is we first, number one here, is we first have to convert the kilograms. The mass here is in kilograms, and we see on our density table that the density is in grams. And typically in a high school chemistry course, the units of measurement for density will typically be in grams per cubic centimeter or grams per milliliter. And because of that, we're going to have to convert the kilograms here to grams first, so that way when we do our mathematical calculations, those units will cancel out. So let's see what we're talking about here. In this problem here, we need to convert kilograms to grams first. So in this problem, we're given 0.543 kilograms. We'll do some dimensional analysis here. We know that 1 kilogram is equal to 1,000 grams. And we put kilograms on the bottom, so that way those two units will cancel out and leave us with grams. And we end up with 543 grams. So this is not our answer. This is just the mass of the sphere in grams, so that way when we do our math with these formulas here, the units will cancel out. We now have grams here and grams here. So now that we've done that, in our second step, in step 2, what we're going to do is we're going to use the density formula, and we're going to solve for V. We're going to find the volume of this sphere. So let's go ahead and do that. If we know that density equals the mass of the object divided by the volume, and we're trying to solve for V here, well, let's first multiply both sides by V to eliminate the fraction. V cancels, and so now we end up with mass equaling density times volume. However, we want to find V, so we're going to divide both sides by D. D now cancels, and so to get the volume, we'll simply take the object's mass and divide it by its density. And so what is the mass of this object? We just figured it out. It's 543 grams. What is the density of nickel? Well, we have a table here of different metals and their densities, and if we take a look right here, we can see that the density of nickel is 8.908. 8.908 grams per cubic centimeter. And so now take a look at what happens. We can see now why we had to convert the kilograms to grams here, because the unit will now cancel out in our mathematical calculations. If we have grams in the numerator and grams in the denominator, they will cancel out, leaving us with centimeters cubed left over as our unit of measurement for volume. And so, yeah, centimeters cubed is a measurement of three-dimensional space or volume, so we know we're on the right track. And when we put this and divide it by this in our calculator and use three significant figures, we're going to end up with 61.0 centimeters cubed. And so that is going to be the volume of our sphere. The volume here we just figured out is 61.0 centimeters cubed. And so what we can now do is plug this volume into the volume of a sphere formula and then solve for R. So in step 3, what we're going to do in step 3 here is we're going to use the volume of a sphere formula. So V equals 4 pi r cubed over 3 formula, and we're going to solve for R. So let's go ahead and do that. And this right here is the same thing as this right here. And so if we know the volume of a sphere is equal to 4 pi r cubed over 3, and we're trying to isolate r and get that all by itself on one side of the equal sign, we're going to have to multiply by 3 first to get rid of the fraction. And what we do to one side, we have to do to the other. And so now 3 times the volume equals 4 pi r cubed. And so now we're trying to solve for r, so let's divide both sides by 4 pi. 4 pi cancels from the right hand side, and so now r cubed is going to equal 3 times the volume over 4 pi. And we're going to have to continue this over here. And so now we have r cubed equals 3v over 4 pi, but we're trying to solve for r, not r cubed. So what can we do here? What we can now do is take the cubed root of both sides. And if we take the cubed root of both sides, what we will end up with is r equaling the cubed root of 3v over 4 pi. And that's that, right? So now we're solving for the radius. What we'll do is we'll take the cubed root of 3 times the volume over 4 pi. And a fancy way of putting this in your calculator will be like this: 3v over 4 pi. And because this is the cubed root, we can put this to the 1/3 power. And notice how I have the exponent in parentheses here. When you put this in your calculator as an exponent, make sure you use parentheses. So let's go ahead and do this. R is going to equal 3 times the volume. Well, we just figured out the volume. It's 61.0 centimeters cubed. 61.0 centimeters cubed divided by 4 pi to the 1/3 power. And when we put this in our calculator, we'll go ahead and put this all in our calculator. And keep in mind, you want to put the exponent here, 1/3, in parentheses when you enter it as an exponent in your calculator. So let's go ahead and put this all in our calculator. And we're going to end up with 2.44 centimeters. The cubed root of centimeters cubed is centimeters. So what is the radius of this nickel sphere that has a mass of 0.543 kilograms? We've just figured out that the radius is 2.44 centimeters. We've used the density formula here to solve for the volume of this nickel sphere. We then plug that into the volume of a sphere formula and determine the radius. So if you like what you see, go ahead and click that little bomb in the bottom right hand corner, and that will subscribe you to my channel. And feel free to leave any comments or questions in the comment section down below. And I really hope you guys found this helpful.